Thanks, Fernando, for the introduction. Okay, so let's get started with our AURES auction designer. As Fernando said, my name is Simone Steinhilber. I'm from Fraunhofer EASY from Karlsruhe, Germany. And I'd like to tell you a bit about the project first, about AURES. So the acronym stands for Auctions for Renewable Energy Support, and we are a coordination and support action under the EU Horizon 2020 program, which I guess is familiar to most of you. It's a 3-year project, which is now in its final year, so we will finalize all our activities by this December. The background when we set up the project was the new European Commission state aid guidelines at the time. So those were published in 2014 and required member states to introduce more competitive elements to their renewable support schemes. And at the time, there wasn't much experience around in Europe regarding renewable energy auctions, and that's why we saw a need to distribute and, well, to collect and distribute more information to renewable energy policymakers. So according to that, our project has 2 main objectives. The first one is to gather new insights regarding auction design and the identification of best practices in auction design. And the second is knowledge building and facilitation of cooperation amongst policymakers, but also amongst market participants and other stakeholders. 2 example questions that we are continuously answering or have answered in this project are which auction types and designs are specifically suitable for renewable electricity support, and secondly, what effects, either desired or undesired, do different design options have under different market conditions. We are 8 partners in this project in total. The project is coordinated by the Technical University of Denmark, DTU, and Fraunhofer ISI was responsible specifically for this auction designer tool. So we've had a lot of activities in the last 2.5 years, including identification. We've done work on identification of auction types and formats suitable for renewable support. We've described appropriate design elements for renewable support and analyzed as well alternatives to auctions where they may not be applicable. We've done auction experiments in the lab. We've collected empirical data and analyzed past and ongoing auction implementations within the European Union, but also outside. And we've conducted case cooperations with policymakers on auction implementations. On our webpage, we provide resources for policymakers or stakeholders interested in auctions. Those include a glossary on auction-related terms and a cash flow type model for individual investors, as well as now the online policy support tool, the AURES Auction Designer, which we will be speaking about today. You can find out more on our homepage, which is auresproject.eu. There you can download all of our reports. You can learn about past auctions, case studies of a number of countries. You can access our tools, as I mentioned, the cash flow tool and the auction designer. And you can also view recordings of an older webinar series that we did earlier in the project. Yeah, but let's move on to the auction designer now. So the AURES Auction Designer is also available on our project homepage now. We've launched it 2 weeks ago, and it's available at auresproject.eu/auction designer. It's a free interactive online tool, which as our main target group are policymakers, but it's also interesting for renewable energy industry or other renewable stakeholders who might want to understand better why policymakers are designing auctions in a certain way. All the content that you find in this AURES Auction Designer are based on findings of the AURES project, the findings that I just introduced previously. It's not possible to provide a ready-made auction design, of course, in such an online tool. But what we do provide is what we can do is to illustrate the main design choices and to illustrate the main trade-offs, the best practices, and the pitfalls that you usually have to deal with when designing an auction. I'll just go through a number of the different design elements that you have to deal with when you're a policymaker that is trying to design a renewable energy auction. And then we'll go through the most common ones, and I will use screenshots from the AURES auction designer throughout, so you can also familiarize yourself with the user interface immediately. So usually, when you're setting up an AURES, when you're setting up a renewable energy auction, you have to deal with a number of questions, including different, what are your selection criteria? So do you want a price-only auction, or do you want to take into account secondary objectives such as geographical diversity, actual diversity, technical specifications, domestic industry development, or grid integration? What kind of scope do you foresee for your auctions? So what is your foreseen auction volume? What is the periodicity, so the frequency of your auction rounds? How will you deal with target achievement safeguards? So how will you deal with amounts that are not awarded, were not awarded or are not built? What kind of price limits do you want to foresee? Do you want to have price ceilings or minimum prices? What kind of payment are your winning projects competing for? Are you planning to pay a feed-in tariff or a feed-in premium or an investment grant? How long are your contracts? How many years will your contracts last? And do you update the remuneration over time? What kind of auction format do you foresee? Is it single or multiple item auctions? Do you want to do static or dynamic auctions, or maybe a hybrid design? And which pricing rule do you want to apply in your auction?
Sorry, Simon.
Yes?
Sorry, Simon. Maybe you could speak a bit closer to the microphone, please.
Oh yeah, sure.
Okay, thank you. That works. That's better.
Yes?
Thank you.
Okay. What are the pre-qualification criteria that you want to set? So these could be about technical requirements, about documentation requirements, preliminary licenses, and deposits and other guarantees, and which effects will this have on your auction results? What are the penalties that you might want to put in place for non-compliance or for delays? And what kind of bidder restrictions do you want to have in place? Or which deadlines or grace periods do you want to put in place? So we'll just enter into the auction, into the AURES auction designer and go through the screens one by one, looking at all these points. So when you enter the AURES auction designer, first you land on a welcome screen where you are asked to choose your country. Let's just say we are a hypothetical user who is from Austria. Let me stress that it's really a hypothetical user, so the things I'm going to enter into this tool have nothing to do with actual Austrian policy making. So our user selects Austria from the drop-down menu of countries and proceeds. And now you land on the second page where you see at the top some information on some background information on installed capacities to date in Austria, as well as planned capacities according to your renewable energy action plans. So this gives you some kind of idea what are the amounts that you would be talking about in any auction that you want to set up here. Of course, if it's a policymaker who is the user of this tool, they will usually have a clear idea of what are the kinds of amounts that they will want to support using their auction scheme. Next, the user can select a technology which they want to take a closer look at, you can either select a multiple technology auction or any of the individual technologies that are listed here. So let's say our user is interested in onshore wind auctions, and then so it selects onshore wind auctions and subsequently fills in all the fields that are required below. So his selection looks like this. He says we are planning to build we're planning to support 600 megawatts of onshore wind in the next 5 years. We ask for a strategy for the next 5 years because we think it's important for policymakers to be clear about their strategy of the next 5 years. Then our hypothetical user says, okay, we will have auctions twice a year, so that amounts to 10 auctions in total over the next 5 years. The volume per auction, he sets at 65 megawatts. That's a good idea because usually we would say if you have 600 megawatts, you distribute that over 10 auctions, that would be 60 megawatts per auction, but it's a good idea to set the auction volume a bit higher because usually you have less than 100% realization rate in auctions, and so you just if you want to stay on your trajectory, on your deployment trajectory, it's a good idea to set auction volume slightly higher. So this auction volume constitutes your demand that you're creating by your auction. And corresponding to this, we ask you what you think your supply is. So the supply is your expected market potential per auction. This is, of course, not easy to estimate for the policymaker, but it's really a crucial value. Your supply must be sufficiently high. By definition, if auctions are going to be a competitive mechanism, supply must be higher than your demand. And the higher the competition, the better. Competition is absolutely crucial to the success or the good performance of any auction. If you are in doubt about how high your supply is, we suggest that you review your demand and, if necessary, decrease it. It's also a good idea to set ceiling prices. It's one of the few things that we generally recommend. Always set ceiling prices when you're doing an auction. Okay, so our user makes these selections and proceeds to the next page. And here we have some information on auction formats. So you can first read, if you're in the tool, you can read a bit about the difference between single item auctions and multiple item auctions. Basically, single item auctions are the type of auctions where the auctioneer, so the state authority, the responsible state authority, usually pre-selects a certain project in a certain location and maybe even pre-develops it to a certain degree, and then lets bidders compete for who will develop this project. In a multiple item auction, multiple projects are accepted. So the auctioneer opens a certain overall capacity or budget, and projects are accepted until that target volume is full. In theory, either format is applicable for any technology, but in reality, single item auctions are more suitable for technologies in which you tend to have few but large projects, where you have long lead times, and where you don't have a lot of projects in the pipeline at any given time, and where grid connection is an issue. For example, for offshore wind, where you need to know where the next project will be situated because you need to coordinate that with new grid development. On the other hand, for multiple item auctions, these are more suitable for technologies in which you have small projects compared to the overall auction volume, where you tend to have shorter lead times and you have a large number of projects in the pipeline at any given moment, and where the grid is largely already there, so grid connection is not such a big issue. So for onshore wind, we would say that is the second type of technology. and the auction tool says that multiple item auctions may be are likely to be the more suitable choice in this case. The tool also provides a number of links here to country case studies that you can follow up to read more about countries that have done technology-specific multiple item auctions. And then the user is asked to select whether he wants to implement a technology, a single item or a multiple item auction. He can follow the above recommendation or not. This is up to the user. We also provide an additional feedback on the supply-demand ratio that the user entered on the previous page, just to make him aware again that the supply-demand ratio is absolutely crucial to the success of any auction. So let's say our hypothetical user agrees with what the tool tells him to do, so he selects a multiple item auction and proceeds to the next page. On the next page, we ask for a number of infos on the bidders and on market characteristics. Why do you need to know this? Well, for example, it's interesting. It's necessary to know this if you want to determine whether a static or a dynamic auction type might be more suitable for you. But also in general, the better you know your market, the better you can also set penalties, material pre-qualifications, financial pre-qualifications. So the better you know your market, the better you can design your auction. Our user says that probably his expected number of bidders will be between 5 and 50. That bidders have good cost information on their projects. They usually have good cost information. So do bidders know their own costs well? They usually do if this technology is mature, if it is well established in your country, and especially if you've previously had a different support scheme, such as, for example, a feed-in tariff or a feed-in premium that was administratively allocated, then bidders can usually judge their costs quite well. Secondly, is there a risk of implicit collusion? Our hypothetical user selects yes to answer this question. And can the auctioneer handle a complex auction mechanism? Sometimes auctioneers have limited capacities, limited staff who can work on renewable energy auctions. So in this case, our user says no, they don't want to handle a complex auction mechanism. And then we proceed to the next page for feedback. So here we get some feedback on static and dynamic auctions. The difference between static and dynamic auctions is that in a static auction, all bidders submit one bid, a sealed bid. At the time of submitting the bid, they don't know what other bidders are submitting. While in a dynamic auction, you have several bidding rounds, and as a bidder, you can observe what the other bidders are doing and at what point they drop out of the auction, and this can give you some hints as to the costs and the situation of the other bidders. Both of these static and dynamic auction types have benefits and drawbacks. The tool here in this little table provides a summary of the answers that that our hypothetical user provided in the previous page. So our user, for example, said that bidders can estimate their costs quite well. This is why this field here is colored in green. And we see that the column with the arguments in favor of static auctions has more green fields than the arguments in favor of dynamic auctions. So it looks like for the market situation and the bidder characteristics of our hypothetical users, it would probably make more sense to do a static auction format. So let's say our user can make a selection down here, and he follows this hint that the tool is giving him and selects static auctions and proceeds to the next page. The next page provides information on pricing rules. Now, I I'm not showing you the full text here, but anyway, there's a confusing multitude of pricing rules out there that you can apply, but they all apply. The choice is restricted by the fact whether you've previously selected multiple item or single item auctions, and whether you're selected static or dynamic auctions. For single item static auctions, you have to decide whether you want a first price or a second price auction. For single item dynamic, it's either the English or the Dutch auction. For multiple item static auctions, it's pay as bid versus uniform pricing, and for multi-item dynamic, it's ascending clock versus descending clock auctions. I will only go into the pay as bid versus uniform pricing rules now, because our hypothetical user has chosen to do a multiple item static auction. So when you compare these two pricing rules, they both have benefits and drawbacks again. For pay as bid means that the bidding projects, the winning bidder receives the price that they bid, while in uniform pricing, all the bidders receive the same price, and that can either be the price given by the highest accepted bid or by the lowest rejected bid. So let's look at the contrast of between pay as bid and uniform prices for lowest rejected bid. Under pay as bid, winners only make a profit if they bid a little bit above their true cost. So this means that risk-loving bidders will tend to post slightly higher bids, and that means the risk affinity of bidders determines their bids. That means in the end you might not have the lowest cost bidders winning your auction, but rather the most risk bidders winning your auction. On the other hand, uniform pricing is incentive compatible, at least if you don't have multiple project bidders. So that means the dominant strategy for each bidder is to bid at their true cost. This is not true if you have multi-project bidders again, as will be the case in most renewable energy auctions. The pay-as-bid pricing rule has the benefit of having clarity of the price which each bidder receives in case of being awarded. While at the uniform pricing, you receive, if you're the highest, if it's lowest rejected bid, you receive usually you receive more than what your bid price was if you're a winning bidder. Uniform pricing brings with it a slight risk of irrational underbidding. Bidders may, for instance, all bid zero, betting on the fact that the last project that will be rejected will have a higher bid price, so they all will receive this higher price in the end. So they themselves just bid zero in order to get in. This works if not everybody follows this strategy. If everybody follows this strategy, the winning price may well be zero, and these projects may make a loss and will never get realized. In theory, with rational bidders, this should not happen, but in practice, it does happen. So there's this slight risk with the uniform pricing rule. Overall, however, we would say that there's a balance between benefits and drawbacks between pay-as-bid and uniform pricing rules. So it's very difficult to say which one is better. In Germany, for example, for the PV auctions, we've tried both pricing rules in different auction rounds, and it seems like the results were very similar. So while it seems like policymakers often spend a lot of time debating on which pricing rule they want to use, actually this is maybe something that just needs to be tested over several auction rounds. So it doesn't make nearly as big as a difference as your level of competition or whether you get your pre-qualification requirements or your ceiling price right, for example. Let's just say our hypothetical user selects pay as bid as his preferred pricing rules and proceeds to the next page. The next page provides some information on the kind of support that the bidders are competing for. So we take into account here feed-in tariffs, fixed feed-in premiums, sliding feed-in premiums, and investment grants. And we provide some information on what are the benefits and drawbacks on these different remuneration types. If our bidder proceeds to the next page, we arrive on the final input page of this tool, and here our user can play around with different design elements and different secondary objectives and see what the result of variations is on auction performance. So for instance, here on this side, our bidder can vary the level of ceiling prices, material pre-qualifications, financial pre-qualifications, penalties, and bidder restrictions, always from lenient to strict or from none to ambitious, and then see what changes in auction performance here on this side. Similarly, he can look at different secondary objectives that a policymaker may have. So secondary objectives are these that are not price. And the possible secondary objectives include actor diversity, geographical distribution, domestic industry development, better system integration, or certain technical specifications. So let's just take a closer look at material pre-qualifications. Next to every one of these design elements, you can click on a Read More icon where you will get extensive information on what exactly is meant by this design element and by which measures you can implement this design element. So for example, here you get an explanation that tells you that material pre-qualifications are intended to ensure that all bidders are serious and have a clear understanding of their own project. Usually material pre-qualifications means that a bidder has to provide certain documentation to participate in the auction. Such documentation may, for example, be project descriptions, a grid access guarantee, a land tenure, environmental permits, or construction permits. It is possible to have relaxed material pre-qualifications for small scale installations. Again, further down, you find some resources on real-life examples. You see a link which guides you to case studies, country case studies that we did in the AURES project, which you can read up on if you're especially interested in this kind of design element. Now, let's go a bit deeper into what happens when you vary material pre-qualifications. If you set your material pre-qualifications to be rather strict, this means that the certainty of bidders about their real costs, so about their real LCOE, will be rather high, because it means that the project needs to be pre-developed to a certain degree, so the project developers already have quite a good idea of, for instance, their wind resource or their geological conditions and so on. On the other hand, all these pre-development costs from the point of view of the project developers are sunk costs. That means sunk costs these costs will not be recovered. If the project does not win in the auction, it's obvious that the sunk costs will not be recovered. But even for winning projects, if there is a high level of competition and bidders bid at marginal prices, it means that sunk costs will also not be recovered for winning bidders. And these sunk costs may deter, so these high pre-development costs may deter certain bidders from participating in your auction. So that means your participating amounts in the auctions will be lower than with lenient material pre-qualifications. Usually it will be the weaker bidders, so the ones with the higher cost projects, who will be filtered out first because they will be first deterred by higher sunk costs and by lower chances of winning. However, if you set material pre-qualifications too high, it can also happen that you actually deter strong bidders, so the lowest cost bidders, the ones that you want to participate in your auction. So you need to be careful to find the right balance here, to not set material pre-qualifications too high to filter out these bidders. Accidental underbidding becomes less likely under strict material pre-qualifications because, as mentioned above, bidders know their own costs better and so don't accidentally underbid due to misjudging their own costs. Award prices tend to be higher also because you have less accidental underbidding. However, the award prices tend to be more realistic. So that means the prices, the projects that get awarded in your auction also have a higher probability of actually being realized. The allocative efficiency tends to be higher as well because with a higher security of costs, it becomes less important when you have a low security of actual costs. The bidders who are more willing to take risks usually bid lower in the auction, and then you might have the bidders, you might award those bidders who are more optimistic because they're more risk-loving, but who are not actually the ones with the lowest costs. So with strict material pre-qualifications, you limit such behavior and you tend to have higher allocative efficiency. What will that look like? So, we recommend that usually you should combine low material pre-qualifications with high financial pre-qualifications or vice versa to balance these different pre-qualifications. What will that look like in our auction designer view? Again, if our hypothetical user sets the slider for material pre-qualifications to very strict, the picture changes as such. So just as I just explained, your realization rate goes up, your support cost minimization goes down. That means your support costs tend to go up. The awarding of lowest cost projects, so that means your allocative efficiency goes up. Number of participating low-cost projects may go down, and participating amounts may go down if you set them to very strict. So that's about material pre-qualifications. Similarly, you can also vary the secondary objectives. For each secondary objectives, you see a drop-down menu. For example, for actor diversity, you can select between no measures to implement actor diversity, or you can have reduced financial pre-qualifications for small actors. You can have reduced material pre-qualifications. You can differentiate pricing rules for small and large actors, and you can implement contingents for small actors. So here, as you see, if you select differentiation of pricing rules for small and large actors, your participation amounts go up slightly, as does the awarding of favored projects. By definition, awarding of favored projects goes up if you implement measures that favor certain types of projects. Okay. Finally, if you move on to our user moves on to the next page, he receives a summary of his selections. And we provide a print-friendly summary of all the content that was selected in the previous pages and that can be printed and kept for further use. And that's it. Thank you very much. For concrete questions on the tool, you can contact me. My email address is here, or for questions on the project in general, feel free to contact our project coordinator or our communication colleague.